Hi, today we are going to see about wireless microphones in this topic. Wireless microphones, the ultimate in mobility is afforded by the wireless because with this there is no connecting cable and the user is free to move around over a distance of several hundred meters. There are two basic types, one where the radio transmitter is contained within the casting of the actual microphone and the other which takes the form of a slim packet unit about the size of a wallet into which an ordinary microphone can be plugged. The integral microphone transmitter unit is rather larger than a normal gun microphone as batteries must be accommodated as well as the transducer and transmitter. In order to obtain sufficient power for the transmitter, the batteries are at least 9 volt, but the size limits the capacity. The average life is 3 to 5 hours, but rechargeable batteries are often fitted to make the instrument more economic to run. With the separate pocket transmitter, a lavalier or tie clip microphone can be used to give complete freedom to the user. The aerial takes the form of a short flexible lead which trails from the microphone. Usual length is a quarter wavelength and the permitted frequencies of the carrier wave. The transmission is picked up on a several special receivers which tunes to the frequency used and demodulates the signal, delivering an audio frequency output which can then be applied to an amplifier or recorded in the normal way. The very high frequency microphone and very high frequency transmitter is shown in this figure. There are 15 frequencies allocated for wireless microphones and all units work on any one of these. Interference is no problem because of the short range, it being unlikely that another will be operating on the same frequency within about half a kilometer. The frequencies are in four groups. Firstly, a group with a wide bandwidth 174.1, 174.5, 174.8 and 175 MHz. The second group is of narrow bandwidth, the frequencies being 174.6, 174.675, 174.77, 174.885 and 175.020 MHz. The third group is also of narrow bandwidth, being reserved for teaching deaf children in schools. In addition, in certain circumstances, the frequencies of 174.65 and 174.95 MHz are allocated for communication on work sites. An ordinary FM receiver will not pick up wireless microphone transmissions. The narrow bandwidth specification is for a deviation of plus 20 kHz and is suitable for most speech applications. The wide bandwidth allocations allow a deviation of plus 75 kHz and give the better quality reproduction required by stage and cabaret artists. The transmitter output power must not exceed 50 mW in the case of narrow bandwidth transmitters and 10 mW with the wideband units. Certain specifications also apply to the receivers. Signal to noise ratio must be better than 30 dB and selectivity such that a signal with a deviation of plus kHz 70 kHz away from the unwanted signal in the case of narrowband receivers and with a deviation of plus 2.5 kHz at 200 kHz away from the wanted signal in the case of wideband receivers will not produce an increase of noise plus unwanted signal of more than 3 dB in the output. An interfering signal of 3 mW should not give a signal in the output greater than 10 dB above noise level in the case of wideband receiver and 20 dB above with that of the narrowband unit. It is possible for any receiver to generate and radiate a signal from the local oscillator which is part of the super heterodyne circuit universally used. The specification stipulates that any such signal radiated from the receiver's aerial should not exceed 2.5 microwatt at any frequency. These stringent requirements serve to protect the user from the effects of jamming and interference. Very high frequency wireless systems is shown in this figure. Thank you.